And broadcasting.
Okay.
All right, welcome back, everyone. Happy Thursday, April 23rd. Can you hear my voice? Bev, can you hear me?
Yes, sorry.
Okay. All right. So welcome back, everyone, and happy Thursday. This is Peggy Hernandez from the U46 School District Planetarium, here for your weekly sky update. Remember, if you're going to go outside and do some observing, please, please, please check your path during the day so you don't trip and fall in a hole or on a rock. So know your territory, get permission from an adult, or better yet, go out with a family member. You will not need a flashlight or a cell phone, and there's a little asterisk there. I'm going to tell you a little bit about flashlights today, and you will not need a telescope to see anything that I'm about to show you. Now, I'm going to go to an animation right away because I want to show you something about Venus, and this is pretty cool to watch. It's only about the speed of the planets. That's all that matters right here. And I want you to focus on the Earth, which is the third one out. And then look for Venus. Venus is the second one out. Watch as the Earth goes around and look at Venus approaching us. Yes, did you see right there? It passed us. So watch again. This is Venus. This is the Earth. Watch as Venus is approaching us closer, 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 closer. Yes, it just passed us. Well, that happens. And when Venus passes us, it looks pretty cool in the sky. Remember last week we talked about how amazing Venus is. It still is amazingly bright this week. You just cannot miss it in the west. It goes down at about 11 o'clock, a little bit north of west. But last week I pointed out something kind of cool, that in September it was almost a full Venus through a telescope, like a full moon. But a few months later now it's shrunk down to about 20%. So it's a crescent. We would call that a banana-shaped moon. But yet it got brighter in the sky during that time. So the shape got smaller, but yet it got brighter. And the reason for that is because Venus is approaching us and it's going to go past us on June 3rd. So here are some pictures from the last time this happened, or a previous time that this happened. In September, it was almost full. It was bigger than half. But ever since then, about every 2 weeks, this is a picture from the same telescope in the same spot with the same zoom. And you can see that it's getting physically bigger in the sky because it's getting closer. We're about right here right now. So we're only seeing a little tiny crescent sliver of Venus, but because it's so close, it's bright. And that's key. Closer is brighter. And that's why Venus is so obvious in the sky. Now, ancient people also noticed that stars had different brightnesses. And a guy named Hipparchus, over 2,000 years ago, he decided, hey, when it starts to get dark out and we see those first stars, like that one right there and that one right there, and there's one there and a little one there, those are the brightest stars in the sky. So we call those the magnitude 1 stars. They're the brightest stars in the sky. And then about 15 minutes later, cleverly enough, these are called the magnitude 2 stars. So these are the number 2s, the next group of stars that shows up. Now, as it gets a little darker, here's the magnitude 3s. 1s, 2s, and 3s, we can all see from the suburbs of Chicago, where most of us are from, suburban or city. Now, when you get to the magnitude 4s, we can usually see these ones, but these dimmest ones here are all 4s. And some of us, if we live really close to streetlights or a parking lot, we might have trouble seeing the 4s. 5s are even harder to see. Here I'm getting rid of some light pollution, but a 5 is a pretty dim star, and any kind of suburban or city light is going to wash them out. And 6 is even more so. A magnitude 6 is the dimmest thing our human eyes can see in a perfectly dark sky, like if you were in the middle of the desert or on the top of a mountain. No light pollution whatsoever. Those are the 6s. So 1s are the brightest, and 6 stars are the dimmest of all. And then there's amazing sun. Sun is a star, and it's a negative 27 in brightness. Why? Because it's so much closer to us. The stars we see at night are out in our galaxy. They're all part of the Milky Way, but they're far. Our sun is only 93 million miles away. That makes it super bright. And if you look at all of this on a scale, The sun is way up here, the brightest thing in the sky. It blinds you if you look at it. It's a negative 27 because it's so close. The dimmest things our eyes can see are telescope objects. And anything over, anything more darker, higher number than a 6, you need a telescope or binoculars to see, but a really good telescope can see all the way to a plus 28. So the range of human eyes goes from 6 to 1, although nowadays in modern times, we've tweaked the numbers a little bit. The brightest star in our sky is actually a negative 1.4, that's Sirius. But the range for humans in suburban skies is about here. This range right here is about what we can see. I'm sorry, the brightest stars to the suburban limit is right here. From super bright Venus, which is about a negative 4 tonight, all the way down a little bit dimmer than Polaris. That's what we can see in the sky. Remember, the higher numbers are actually dimmer objects. And it turns out that Hipparchus was pretty much right. Stars that are closer are brighter, because that makes sense. We can figure out how far stars are, even though we've never been to a star. We've looked at them. We can look at the sky in July and spot a nearby star, and it might look like that through the telescope. But 6 months later, when we're 187 million miles away on the other side of the sun, that star looks like it moved. Well, this difference in movement is called parallax. And what we can do is we can calculate this angle, which means we can calculate this angle. And if we know this distance, we can figure out how far that star is. And we figured out that the closest star to us is about 25 trillion miles away. Look at all those zeros. 25 trillion might as well be a gajillion. Miles is too small to use for measuring stars. So scientists often use what's called a light year. And it's the distance that a photon of light travels in 1 year. If you just let it go at 186,000 miles per second, that's 1 light year. The closest star is 4 light years away. That's easier than saying 25 trillion miles away, in my opinion. That's how many miles 1 light year is. 1 light year is about 5.8 trillion miles. The nearest star is 4 light years away, Alpha Centauri. And when we look at stars, they don't look like they're different distances. Here's Orion the Hunter. But if we were to pull the stars back to their actual distance from us, from planet Earth, this top one in the corner is Maesa. That's the closest one. Safe is also pretty close to us. Here's Rigel, here's Mintaka, one of the belt stars. And right here is Betelgeuse. But Betelgeuse is the brightest star in that group. So something's a little odd because this one is not the closest, but yet it's the brightest. See, it turns out it's not just distance. There are some other things that can affect how bright stars look from the sky. And here is an example of the sun and some really big other stars. The sun is a small average star, but Arcturus is a particularly giant star. So our sun is a negative 27 and it's only 9 light minutes away from us. It only takes light 9 minutes to get here. It's only 93 million miles. Sirius is 8.6 light years away, but in the sky, it's a negative 1.5. See, it's not a huge star, but it's white. It's particularly hot. Extra hot often means extra bright. And here's another example. Now look, the sun is a pixel in this picture. There's Pollux and Arcturus that I had on the last slide. Look at Betelgeuse. Betelgeuse is 643 light years away. That's really far, but it's a supergiant. It's so extra big. Sometimes supergiant stars can look a little brighter in the sky than they should based on their distance. It's amazing. We can look at stars in the sky. We can use our tools looking at the light from the stars to figure out how far away they are from us. You know, when you put white light through a prism, it breaks up the light into all of its wavelengths and you get what we call a rainbow. Well, if you study starlight through a prism or a device that acts as a prism and allows you to study the spectrum, it's called a spectroscope, you see the rainbow, but you also might notice these lines. Well, it turns out that every element in the universe, every element that we know of on the periodic chart, as light goes through or comes from an object that has an element in it, it gives it these characteristic lines that are always in the same spot. So when a scientist aims a spectroscope at a star and sees this exact pattern of lines, they know that they're looking at hydrogen. There's nothing else that makes those lines. So even though we've never been to any star, we know that that stars are made of almost all hydrogen. And there's also some helium and then hundreds of other elements in differing amounts as well. So you can look at the starlight through a special tool called a spectroscope, and we know what elements are out there. It's pretty amazing. When we look at stars, either a small or a large one, they're made of hydrogen and helium and a few other trace elements. But large stars can turn into red supergiants, not just giant, supergiants. And every once in a while, those stars explode in a supernova. Now, scientists have studied the light coming from areas where there was a supernova, and there's all sorts of elements, not just hydrogen and helium. There's heavy elements like iron. You know, the amazing thing is our Earth, in the center of it, it's almost completely iron and some nickel. And it turns out that many scientists think our solar system formed in the spot of an ancient supernova. Okay, so what's up tonight? The cool thing this week, I think, is going to be the moon slipping past Venus. Now, tomorrow, Friday, we're going to have, it was a new moon yesterday. It was, in other words, it was right next to the sun. But every day the moon moves a little bit in its orbit. So we're going to have a tiny little crescent this week. Friday, this will be so close to sunset, you won't see it. But maybe by Saturday, it'll be in Taurus the Bull, that letter V. That orange star is the eye of Taurus the Bull. On Saturday, it's going to be right next to Venus. Oh, I'm sorry, on Sunday, right next to Venus. And then on Monday, up and to the left, Tuesday, up and to the left, Wednesday, up and to the left, and every day getting a little bigger as it moves away from the sun. The other cool thing is in the really early morning sky, and we have the International Space Station. I'm going to show it to you when we go to the live sky on Stellarium. It's going to look like that when it shows up. And in the upper left, it'll say ISS. And in this example, it's just barely above the trees and houses. And this is tomorrow at 5:17 in the morning, so early morning, and it's barely above the houses. That is actually not super easy to see outside. So I went to a website called Heavens Above, and I put in the date in our area where we live, and look at this. On April 24th, 6, 7, twice on the 28th and the 29th, the International Space Station is going to come by, and look how bright it is. You know these numbers now, they're all negatives. They're brighter than the brightest stars in the sky. And on the 28th and 29th, those are as bright as Venus, but they're all early morning. I think the 5:17 a.m. on the 28th, -3.6 will be the best one, because if you go over to this line here, the highest point it reaches, 67 degrees up, 90 degrees is straight up, 67 means we're all going to be able to see it in the sky. It won't be in front of any buildings or trees, unless of course you stand under a tree. Don't do that. Go out in the open. Now tonight we're going to also see the Big Dipper. Like every night, we can always see the Big Dipper. The two stars in the saucepan, if you act like you're pouring something out, they always guide you towards Polaris. And since we talked about brightness of stars, I have to point out, Polaris is a magnitude 2. We have hundreds and hundreds of magnitude 1 stars that are brighter than Polaris. I know there's an urban legend out there that Polaris is this glorious bright star. It is absolutely not true. Polaris is actually about the 48th brightest star in our sky. Number 48, it's not even in the top 10. It is special though. There's a reason why we call it the North Star. It is directly above the North Pole of planet Earth. And we spin on that pole. We rotate on that pole. Now I have an animation I can show you, and I want to use this just so you can get your bearings. And I have it set up so that the person, that circle, is at 42 degrees latitude. That's where we live. We're 42 degrees above the equator. The blue line at the top and the bottom, well, that's the North Pole and the South Pole. That's what we're looking at there. And what I can do is I can switch this back and forth. Now pretend like you're that human on Earth in that circle. The horizon always looks flat all the way around you. North is towards the North Pole. Straight up above you is not north. Straight up above your head is out into outer space. North is always towards the North Pole of planet Earth. So north would be this way, south would be this way. And if we look at it from the side, you can see that the North Pole for us is, well, about halfway up between the horizon and straight up in the sky. Now I can go back. This is the same person, basically the same view. We're going to shrink it down. So imagine that little person was standing right there on that disc. Their sky looked like that. And here we are. Looking straight up does not take you north. It takes you out into outer space. But if you look towards the North Pole, you'd be looking north in our sky. Okay, so now I want to go back to this. Oh, it isn't from here. So this is a diagram with a lot more lines of the same thing I just showed you. So here's a human standing on planet Earth. You know, the big, huge Earth is underneath this person's feet. The sky is like a dome. But that North Pole of the Earth points to the pole star, Polaris, which is the North Star. Well, because of that, if you're on planet Earth and you look right at Polaris and you stare at it for hours and hours, what you'll notice is that the whole sky is spinning around that star. If you take a picture of it, it looks like this. That's the North Star in the center. This is probably 2 or 3 hours of the camera being open while the Earth spins underneath the feet of the photographer. Here's another view of the same thing. The North Star is right there in the center, so I know they're looking north in this diagram. This is from the South Pole. There is no South Star. If you live below the equator and you look towards the South Pole, you'll see a group of 3 stars, but there's no single star that stays in the same spot. These are the clouds of Magellan, different galaxies. And one cool thing you can do, as young as kindergarten all the way up to grandma and grandpa, you can use a star clock to figure out the correct time. You can download this easily on the internet. It's on the planetarium portal. Star clocks are everywhere. You would cut both of these out. The hardest part at home will be finding a brad or something that will work like a brad, because you puncture the brad right through the North Star. And when you hold this up with April up at the top, like at the 12 o'clock point, then you spin the black disc until you get to the time you want. So for example, tonight, if you go out in April at 9 p.m. and you look north and you find the North Star, the Big Dipper should be above it to the right, spilling out, and Cassiopeia should be underneath it. There's lots of different ways to, there's lots of different star clocks out there you can use. And know that when you're out there in the dark, you might need to see your star clock. So you can take that outside with you, but get a flashlight and put some yellow cellophane over it. Again, I know you might not have this exact thing at home. Red cloth might work. A couple layers of some kind of red colored cellophane would work. If you can find a plastic bag that's red and wrap it around it, that would work. This won't ruin your night vision. You can look at your star clock and then look up at the sky, and your eyes will still be able to see stars. There's lots of different versions of this out there. You could easily print out this one. You cut out the circle and then you put it with a brad, stick a brad through Polaris. And again, I lined this one up. If I spin the top disc around, we got April at 9 p.m. Once again, it shows the Big Dipper up and to the right and Cassiopeia down and to the left. We're going to check that out. These are all different types of star finders. You can use them all. They all work. You got to line up the correct date and time. As the Earth goes around the sun, our view changes. And you can go to the planetarium portal and get those PDFs of those star clocks. That would work. And we're going to move on now to Stellarium so we can take a look in real motion what's going on with our sky. So this is right now. This is 4/23/2020 at exactly 1:19 in the afternoon. And here we go. I'm going to fast forward time a little bit. Now I'm going to go a lot. 2 o'clock, 3, 4, 5, 6. Here's a little bit before 7. And our sun is setting this week today at 7:44. Notice before it even hits sunset, we're at 7 o'clock right now. You can kind of see Venus. It's just starting to become visible. The sun actually sets at 7:44. So I think we're just going to let it go down in the west, northwest, and then we'll pause at about 8:30. Let's go to 9 o'clock. 9 o'clock would be a good time to start observing. So we'll see the magnitude 1s and then the 2s. So right here is sunset. Stars will be showing up. There they are. There's the 1s. Oh, here's the 2s. Here's the 3s. 8:30. Almost full dark. We got to let that sun go down. The moon was there for just a moment, little tiny sliver crescent. It's already gone. And if I go to about 9 o'clock and pause here, these are the stars you can see tonight. I have this nice and dark. I don't have a lot of light pollution showing because I want you to be able to see everything that's out there. I'm noticing a lot of satellites that are going by. That's perfectly normal. It happens every single night. In real time, they would be a little bit slower than that. I was fast forwarding. But notice tonight, you will definitely be able to see some constellations. I'll give you a moment to see if you can't recognize anything. I'll add in some lines. This is looking west tonight. Most notably, you'll have Orion the Hunter close on the horizon, pretty low. Right above it, the twins, Castor and Pollux of Gemini. Capella is the bright star up and to the right from Venus. It's in the constellation Auriga, the charioteer. And the red star below it, or to the left, both of these are red giants. So Betelgeuse or Aldebaran in Taurus the bull. So there's the drawings and there's the names of those constellations. Now, if we were to look up a little bit higher in the sky, so if I were to turn my head to look up a little bit higher in the sky, so I'm above 90 degrees is about right here, the exact middle of the sky. And right there, we're getting to see the Big Dipper, that if I were really looking at this, I would have my head upside down behind me. So I would probably just turn around and look north to see that one. I'm going to turn my body. I'm just going to spin to the left and get us looking at the southern horizon tonight at about 9 o'clock or so. Tonight at about 9 o'clock, it'll look like this. Take a look, see if you can spot anything familiar. There's some lines. Here's their names. Leo the lion, probably the most noticeable one up high in the south. As soon as it gets dark out tonight, looks like a backwards question mark. Then his body is behind him. I always imagine a cat kind of like in a sphinx position, like cats like to sit on the back of the couch. Corvus the crow is another pretty obvious one to notice at home. It's not too high up in the sky. So this is what you would see in the south tonight. And then we're going to continue spinning our body. We're going to look towards the east. At around 9 o'clock tonight, it'll look like this. Here's the constellations that are up in the east. That bright star Arcturus is a red giant. It's about 36 light years away. In the constellation Bootes, it's the shepherd, but I think it looks like an ice cream cone lying on its side. Goes across the sky all summer long, rises in the evening and is up all night long. Notice we can see Draco the dragon, and we're actually kind of aimed towards the north a little bit here too, because here is the Little Dipper and there's Polaris. So if we continue to spin to the left, we'd be facing north. If we face north, hopefully you can notice some constellations you recognize. The Big and Little Dipper are right in front of us. Here's the Big Dipper. The pointers aim us at the Little Dipper. And if you keep going in that line from the Big Dipper, it takes you all the way here to Cassiopeia. Hey, it's lined up exactly how our star clock said it would be. The Big Dipper is spilling out. Polaris is down and to the left, and continuing down, you'll be at Cassiopeia the Queen. This is what it'll look like at about 9 o'clock tonight. Now I want to fast forward time. I want to show you that neat, amazing feature of the North Star that actually makes it famous. This right here is the North Star. Right here is the North Star. Watch what happens when I fast forward time as the night goes on. You ready? Here we go. Go a little faster. Here we go. There's the North Star. All the stars are rising up on the east side and going down on the west side. Any star that's within 42 degrees of the Polaris for us is visible all night long and all day, only we can't see it during the day because the sun is up. Even though the sun is up and it's bright out, I'm going to leave these lines on so you can see them. I mean, I think I could actually, yeah. So the sun is up, it's actually daytime, but I can turn off the daytime light so you can watch. 24 hours later, we're going to be right back where we started because the Earth will have done one full rotation. The North Star is still 42 degrees above the horizon and everything constantly spinning all night long. So it's still daytime. Now it's 4 in the afternoon, 5, 6, 7, 8, 9 o'clock tonight again. And we are back where we started. The Big Dipper's up here and Cassiopeia is down here. Now, if you were to look behind you in the south, the movement looks a little different because they're all these objects in the sky, they're out opposite the direction of the North Pole. The North Star points, the North Pole points to that North Star. And if I fast forward this view for 24 hours, there's no star that stays in the same spot. Everything goes east to west. Now I'm going to stay up all night because I want to go to sunrise and I want to face east. I'm going to watch the sun come up. So here it is, 4:10 in the morning. Let's go a little bit faster. I think the next step is too fast, but let me try. No, it's not. It's almost 5 o'clock. The sun actually comes up in the 5 o'clock hour now, you guys. We're getting close to summer. It comes up at 5:59 today. That is a satellite. That's a particularly bright one. That is not the International Space Station, but that one will be coming by at 5:21 tomorrow morning. Oh, we're on the 26th, wrong date. I'm going to pause here. I want us to see tomorrow morning because that was the first day the space station was going to be visible. I got to go to 5:17 because that's the International Space Station there. So here it is, 5:16 tomorrow morning. Notice the sun's coming, just starting to come up. It's visible, it's noticeable. But if I fast forward a little bit, that's what the International Space Station looks like. It moves slow and steady across the sky, no red and blue lights. It's really low though. It skims along just above the horizon. If you lived in the middle of a wheat field, it would be perfect. But we have trees and fences and garages and the neighbor's RV, and sometimes it's hard to see things that are that low. So if I pause and fast forward to that time, 5:17 on the 28th. So let me go back a little bit in time. So we're 2 minutes before this starts on the 28th, 25, 26, 27. Here we are on the 28th. Notice that there is a little bit of light on the horizon. And I might need to back us up a little bit so we can see more of the sky. There we go. It should show up around 5:17. Anybody see the space station? Yeah, I don't either. So it's in the sky right now and I can't see it. So that tells me that I must be looking in the wrong direction. I'm going to try to zoom out a little bit. Please forgive me if I hit the wrong button here because I went the wrong way. Let's try this. There we have it. That's why we weren't seeing it. It's coming from the west, southwest to northeast. It's going to cover the sky on that morning. And notice it's way up in the middle of the sky. It's going to come from right overhead. That'll be really, really neat to watch. If, of course, you like getting up at 5:17 in the morning, well, get up at 5:10 and stretch a little bit and go outside and face west on that date, the 28th, you'll be able to see it. And again, you can go to Heavens Above and look for any of these, the space station sightings, and watch them on your own. Just set an alarm on your phone and go out and watch. It's really, really neat to check out. Okay, so showed you a lot of cool stuff today. And I think we are ready to go to questions. So let's do that.
Hi, Mrs. Hernandez.
Well, hello there.
One of the first questions here is about zodiac signs. And so the question is, can you see zodiac signs in stars?
Can you see zodiac signs in stars?
Yeah, I think they're noticing maybe the connection between some of the names, maybe.
Yeah, that question sounds to me like someone's a little bit confused about what they even are. Because a zodiac sign is just a constellation in the sky that at some point during the year is actually right behind the sun. The sun comes up and there's a constellation right behind it. For example, let's fast forward a little bit today and see what sign is behind the sun today. So notice the sun's coming up. Yay, it's morning time. So here it is 7:30 in the morning. We get a little bit higher so we can see it easier. It's 8 o'clock in the morning. Now it's 9 o'clock in the morning. And I'm going to stop right there and I'm going to let it get dark. And then I'm going to put up the pictures. And if I zoom in a little bit, it looks like Aries, the ram, is right here. So the sun and Aries are right next to each other. So a couple thousand years ago, ancient observers of the sky, they decided that that meant something supernatural. Like if a baby was born, like at this very moment when the sun was right in front of Aries, that they would be called a ram the rest of their lives. And that's what they're assigned. And that makes them Aries. And the sun is in this spot in front of this constellation for about a month. Remember, the earth moves around the sun. So every day our view of the sky shifts a tiny bit. I can show you that. So today's April 28th. Let's shift to the 29th. Hey, here's April 30th, right at whatever we said, 9 o'clock, 10 o'clock in the morning. And here's May 1st and May 2nd and May 3rd. And here's May 4th and 5th and 6th and 7th and 8th and 9th and 10th. Ooh, Mercury zipped past the sun. That was kind of cool. May 11th, May 12th. Hey, by May 13th, 14th, 15th, we're in this one now called Taurus the Bull. So if you're born on May 15th, you're probably called Taurus the Bull. And the people that made up these signs are just people that imagined creatures in the shapes of the stars as they randomly appear in the sky. So I think that answers the question.
All right. So the next question is, first of all, it's a comment. This is so interesting. Can you give us the link to the star clock?
Yes. If you go to the planetarium portal, and if you don't know how to go there, go to the U46 website and click departments. and you click My Department. That's Observatory Planetarium. And when you get to the Observatory Planetarium page, right up there on the right side, it says, click here to go to the planetarium portal. And in the planetarium portal, I have some content resources for students and families, and you click on that and you can find it there. Or if you're young and you're with an adult, or you're an adult, just Google star clock. And there's several different kinds. You can just click on them, and Sky and Telescope, earthsky.org, the Astronomical Society of the Pacific, they all have links where you just go right to the PDF and print it out at home. I think the hardest part might be getting creative if you don't have brads at home. If you're not crafty, you probably don't have any at home. But you can be creative and use just about anything if you can poke it through and bend it somehow and allow that paper to spin, and you can take it outside. And if you know the stars, you can figure out what time it is and you don't even need a watch. Or if you know the exact time, you can use your star clock to go outside and find where the stars are in the north. The star clock is just for the north stars, just towards the Big and Little Dipper. A full star chart does every direction, but it's usually easier to start simpler. That's why I would say start with the star clock.
Is the sun the brightest star?
Well, if you go back in the recording to the beginning, it is definitely the brightest star in the sky. I almost go blind when I'm outside, not even looking at it. I need to put sunglasses on. It is so bright just to drive my car when the sun is out. So without a doubt, the sun is the brightest star during the day. Oh, it's not the brightest star in our galaxy. Oh no, not even close. Most of the stars you see at night are way brighter than the sun if you line them all up next to each other. So why does the sun look so bright? Well, it's so close to us. It's only 93 million miles away. Those other stars are trillions and quadrillions of miles away.
Here's a question about Saturn. And they're asking about in relationship to size of Mars, is it bigger? But maybe it'd be good to kind of talk about the different sizes of planets. And then I'm also wondering if maybe part of the question is, well, when they look at them in the sky, they seem to be about the same size, perhaps?
Yeah, that could be a little bit of both. And for sure, Jupiter, Saturn, Uranus, and Neptune are all way bigger than the rest of the planets. And the first four planets where we live, Mercury, Venus, Earth, and Mars, those four planets are much smaller than the gas giants. Now the gas giants that we can see, Jupiter and Saturn, are way farther, but they're also way bigger. And that bigger allows the sunlight to hit it, and the sun hits a bigger target. So when you look at that planet, you can actually see Saturn and Jupiter in the sky, even though they're really, really far away. Now Venus is way closer, but it's way smaller than those other stars. And it turns out that in the sky, planets that we can see just look like bright stars. They just look like bright dots in the sky. That's a really good question. That shows me that you're thinking about the scale and comparing different objects out there.
It was a really, really good question. Here's another question. I'm not exactly sure what the participant is wondering. So whoever asked this question, if you want to rephrase it, if I don't get it right, feel free to. The question is, how did the moon come to be in the north? And so I'm wondering if maybe you could tell us how the moon was formed, and maybe, why it seems to be affixed in one location, maybe. I think they're thinking it stays in one spot, the moon.
So the moon generally crosses our sky in the south. And that the north part is what's confusing about that question, what the person means. But the moon moves around the earth, and every night in the sky, if it's up, if it's on our side of the earth, from one day to the next, the moon moves about one fist. If you hold your fist up straight out, the moon moves about one fist, and 28 fists later, 28 days later, the moon will be in the exact same spot. From where we live on planet Earth, above the equator, we pretty much always see the moon in the south. because the moon goes around the earth pretty even with the equator. And we live north of the equator. So to see something towards the equator, we always look towards the southern sky. Now, if you lived in Australia, if you lived south of the equator, when the moon was up, you would actually have to look in the northern sky to see it. So it can be up in the north if you live in the southern hemisphere. There are also times of the year when the moon rises in the northeast or sets a little bit in the northwest, but it crosses the sky in the south. I hope that answers the question. And if not, hopefully that person will rewrite their question or ask another clarifying question that we can get to.
I think that you did answer it because they did send a clarifying question, and it was about, is the moon in a pattern like stars? So I think you answered it.
Yeah. And I think that an entire session on the moon might be in order. I know we talked about patterns last week, and that's on the recording for last week. If you want to go see some of the patterns that people have noticed over many, many, many years on planet Earth of things out in space, patterns that happen because we go around the sun. I did not focus on the moon yet, but the moon definitely changes in a pattern without a doubt. It gets bigger for 2 weeks, and then it gets smaller for 2 weeks, and bigger for 2 weeks, and smaller for 2 weeks. So we go from a full moon back to a full moon in 4 weeks. That's a month. It takes the moon 1 month to go around us. So there's definitely lots of patterns to notice with the moon. There's even patterns that repeat every year with the moon. Like in the winter, the moon, when it's full in December and January, it crosses very high in the sky, very high in the south. But in the summer, our moon is always a little bit lower, and it has to do with the Earth's tilt as it goes around the sun.
Here's 2 questions related. They're from different people, but they're about star clocks. So I think one person is wondering, well, how does, what is a star clock? They heard your explanation, but I think they're still not clear on what a star clock is. And then the other person wanted to know who invented a star clock.
Well, I couldn't tell you a person that invented a star clock, but I'm going to guess it was probably somebody really, really ancient, because when they sat outside and were outside for hours and hours, they would notice that it did this spin around the North Star. So all they'd have to do is make some kind of a tracker, and they could actually measure time. So the first person to make a star clock must have been an ancient person. Now, the star clocks that we have on the internet, like this one, this is a simple star clock, and this is the one I showed in the diagram, and I'll spin it here and let you see it. The black disc on the spins because I have a brad right here, and it's poked right through the North Star. Now, I look at the months up here, and when I hold it outside towards the north, I'm going to want to hold it so that April, which is the month we're in, April, I'm holding it up in like the 12 o'clock noon position. Like if this really was a clock, 12 noon, 12 would be right here. So I hold that still as I'm facing north, and then I spin this around to the correct time. So at 4 p.m., it's not dark out yet, but let's say I go out at 9. Let's say I'm going to stay up late. I'm going to go out at 11 p.m. That tells me that the Big Dipper is going to be straight above the North Star, and Cassiopeia is going to be below it. And if I stay up really, really late, like way too late, and I'm still up at 3 a.m., I could use my star clock if I hold April straight up, and I should be able to go out and see the Big Dipper over here now and Cassiopeia here. And as the night goes on, at 5 a.m., when the sun starts coming up at 6 a.m., I would notice the Big Dipper is all the way down here and Cassiopeia is up here. So this represents the spinning of the Earth, and you can use it to tell time. If you spot the stars and you say, oh yeah, there's the Big Dipper straight up there, and it's May, so that tells me it must be 9 p.m. Or if you don't know the stars and you know that it's going to be May and you're going to go out at 10 p.m., you would say, okay, I'm going to hold May up at 12. This is where I should find the stars. So it helps you find the time if you know the stars, or the stars if you know the time. It's great if you're trapped outside without a watch. And you have a flashlight with red cellophane. Cover it with something red. You do not want it bright. It'll ruin your night vision. But if you have a red cellophane or red cloth that you put over it, you use this, you can look at your star clock, and it doesn't hurt your eyes. And you're like, oh, you can look up and still see the stars because you didn't ruin your night vision. Hope that helps.
That's a great tip for everybody. So I think you've already answered this question, but it made me think of another relation. The question is the sun the hottest star? And I was wondering, is the connection between hottest star and brightest star, is that correlated? A causation?
Okay. Those are great questions. The sun is not the hottest star. Stars do have different temperatures on the surface. I don't have all the exact ranges memorized, but I think in Celsius, the hottest stars are around 30,000 degrees. And the cool thing about temperature is it changes the color of the surface. Just like when you look at a fire, when something gets red hot, well, red hot is hot, but white hot is even hotter. So when you're looking at a flame, for example, there's the red part along the outside of a flame, but that white, yellow part in the center, I'm just thinking of a regular oil candle, that's actually the hottest part of the flame. And blue-white is hotter than the red oranges. So when you have a really hot star like Rigel, that's the opposite corner of Betelgeuse in Orion, the star looks bluish white in the sky. It actually looks that color. We know those are really, really hot. And it turns out that inch for inch, a hotter star is a little bit brighter. They give off more light. But if they're farther away, that can cancel that out. So it can get a little bit complicated. Medium temperature stars are yellow, like the sun. So it's a medium star, medium temperature, medium size, will never blow up, can never ever supernova because it's not nearly big enough. And the coolest stars on the surface are the giant stars. They're red. Red is the coolest temperature on the surface that a star can have and still be called a star. So, and those actually look kind of red in the sky. And those inch for inch are not quite as bright as the hot stars, but they're often giant. So it being really giant can cancel out the fact that it doesn't give off quite as much light as a star that's hotter. And we can figure all these things out by looking at a star through a telescope or with special tools like a spectroscope or an X-ray detector or whatever kind of detector. We can find out all these things without having to go to stars. We can do it by looking through telescopes.
Speaking of naked eye versus telescope, this participant would like to know if you can see Saturn's rings with the naked eye.
No, not at all. Saturn looks like a Venus in the sky, not quite as bright. It looks like a white dot in the sky with just your eyes. But it doesn't take a very strong telescope to start to be able to see that it's not perfectly round. As a matter of fact, Galileo, over 400 years ago, when he took a spy telescope, and instead of looking, for enemies out in the ocean, he looked at the sky and he said that Saturn has ears. And of course, people were like, this guy is crazy. What is he talking about? Well, what he was detecting was the bulge that comes out near the equator. And he thought it looked like a little face with ears on it. And it turns out those were Saturn's rings. And his telescope was not very strong. So your average 4-inch telescope would definitely be able to see at least the bulge of the rings. And of course, the better telescope you have, the better view you'll have. But you need a telescope to see the rings of Saturn. And you would need a telescope to see the phases of Venus. Like right now, if you wanted to go out and look at Venus right at sunset and aimed a telescope at it, if you had a good telescope, you could tell that it was a banana shape. It's not a full circle of the planet Venus. It's got phases just like the moon.
So this question is it possible for a star to pop? And I think probably what they mean is, for them to burst.
Yeah, they don't pop. They don't burst like you would. I'm picturing a balloon, like if you stick a pin in a balloon, they don't do that. but near the end of their lives, stars do change. And a star like our sun, an average, boring, regular sized star, it'll actually swell up. It's probably going to swell up about out past Jupiter in about 5 billion years. So please don't lose sleep over it tonight. That's called a red giant phase. It is absolutely, definitely, positively not an explosion. It's going to hang out like that for a while, and then it will shrink down into a little tiny star called a white dwarf, much smaller than it is now. But really big stars, like not very often, really, really big stars, like in our galaxy, once every 100 years or so, they explode. The supergiant of the most massive, big, superly huge, biggest stars, they can explode, and that's called a supernova. And it's the most gigantic explosion known to mankind. It's huge. And because of the extreme temperatures and the extreme pressures in that explosion, nuclear fusion creates more than the lower, simpler elements. We get all the way up to iron, spewing out in every direction in those supernova remnants. Good question.
Here's another really great question, I think. It's about telescopes. And I think what the person is asking is, can you get any telescope and be able to see any planet? Or, are there different kinds of telescopes or strengths of telescopes that allow us to see different structures?
Yep, good question. The answer is no, you can't get any telescope. If you go to a gift shop at a museum and they have like a little plastic telescope that you can buy, I pretty much guarantee you won't be able to see anything out of it, because you need really high quality glass in the optics for you to be able to see things clearly. And that's the big difference. Sometimes you can find a really inexpensive telescope-like toy and it will magnify things, but they're best just to look for a tree across the street or something in the park down the street. And at night, they don't let in enough light with the magnification for anything to be seen clearly. So if you're really thinking about a telescope, you would want to start with, honestly, Googling, doing some research, best beginner telescopes, and some really trustworthy optics sites. Thousand Oaks Optics is one, Rainbow Optics, or Sky and Telescope, or astronomy.com, or the Astronomical Society of the Pacific. I think every single one of those has a section on their website of how to pick out your first telescope. You're not going to want to do high magnification. You're going to want to spend the money on better optics, better glass, better coatings, and a better stand on it so it doesn't shake while you're trying to look through it.
Are there ways that a person could make a telescope themselves?
Oh, yes. It was very, very common in the 1960s during the space race. As a matter of fact, at the planetarium in the basement, there's what we call the telescope grinding room. And I think it's safe to say hundreds of students made telescopes down there, usually a 4-inch, about a 4-inch reflector is what they made. You do need some special equipment. You'll need to buy stuff from like optics manufacturers, but you can order those things online now. And again, I'm going to suggest that you Google how to make a telescope, and it'll walk you through the steps. There's lots of books out there on how to make telescopes, and they can be done. It's stuff you can go buy at the hardware store sometimes. There's a million different ways you can do it, but you need a tube and you need a lens. And if you're going to do some kind of reflector, you're going to need mirrors, and you're going to need a way to measure them. But it can be done. And the other suggestion I would have would be your local astronomy club that would probably have people in the club that have made telescopes before that can give you great advice because they've done it. And we have the Northwest Suburban Astronomers. There's one nearby, the Fox Valley Astronomical Society. There's the Naperville Astronomical Society. Again, if you Google astronomy clubs, they'll all come up on the internet.
A couple different categories of questions. So one is, what year was a supernova recorded? So it might be good to tell people about supernovas. And then one other person is wondering about dwarf planets.
Okay, so yeah, two different things here. So when was the year there was a supernova recorded? Well, I mean, they're all the time. Astronomers have telescopes that look in other galaxies. And in our galaxy alone, we have one about every 100 years. So there's, supernovas that happen all the time. You just have to know where to look and how to find them. You can't walk outside and see a supernova. They're not close enough. They're happening in other galaxies. And if they're happening in our galaxy, you can occasionally see them, well, about every 100 years. And it turns out the last really big bright one that happened in our galaxy was in 1054. So this might be turning into like a quiz thing again. I'm not sure, because it sounds to me like somebody knew the answer to that question when they asked it. But in 1054, the Chinese people documented this amazing thing. A great white splotch appeared in the sky. I don't know what else to call it. Bright thing. It looked like somebody took a paintball and threw it in the sky that was white. It was so bright you could see it during the day. It lit up the night like daytime. That's what they wrote. A couple of other cultures around the world also mentioned it. The Chinese people, though, were very diligent about documenting. Good scientists do that. They wrote everything down, they measured it, they watched it, and after about a month, it just faded away. Well, then along came telescopes. And 400 years ago, Galileo and his friends said, hey, let's aim it at that spot that the Chinese people talked about. Let's see if there's anything there. So they looked up the documents and they figured out where they looked, and lo and behold, there's a huge nebula you can still see today. It's called the Crab Nebula. And the explosion occurred in 1054, and you can still easily see it in the nighttime sky with a telescope today. So they happen. They happen, but it's not like a science fiction movie where like, oh, we're all gonna die. There's a big explosion. It's a supernova. It's not like that at all. But there are people who spend their whole life studying supernova and the effects and what happens and the energy and the mass and the gravity and why they happen and where they are. And you do that by using special tools that stare out in space really, really, really far away. It's very interesting stuff.
Yes. Well, and so this question is about how old is the planet and how do we know? Which got me thinking about, do we know how old the universe is?
Well, there's educated guesses made about the age of the universe, and it's somewhere around 13.5 billion years old. And our solar system formed approximately 5 billion years ago. And scientists study so many stars, they figured out the life cycle of a star, like what happens when it's young, only a couple billion years old, and when it's old. And our sun is pretty much a middle-aged, middle-class star, and it should last about 10 billion years. So that puts its current age at about 5 billion years old. And yes, there's ways that we can study the Earth and things that have happened and put those together and figure out how old they are.
We have 2 minutes left. Do you have any final words or reminders about what we should be looking for in the sky?
Yeah, I think one thing I skipped on accident was that morning sky. We go out in the morning on, say, tomorrow, 24th. And we're facing east. I want to switch to not 10 a.m. We'll go back to about 5 a.m. There's 3:30 in the morning. And we are going to have these planets coming up. We've got Jupiter and Saturn. I'm going to get rid of some of the distractions. And Mars. So this is facing east. We're at about 4 o'clock in the morning right now. By 4 o'clock, all three of them are up: Jupiter, Saturn, and Mars. Mars is in a spot in its orbit around the sun where it's actually moving towards the sun from our view. So every day Mars is getting closer and closer to the horizon, and it will disappear soon. Venus is going to do the same thing. By mid to late May, We're not going to be able to see Venus in the evening sky because it's going to be getting really close to going in front of the sun from us. It won't go directly in front of, we won't have any kind of a transit, but early in the morning, we've got those 3 planets up. And then at 5:17 tomorrow is when we should be able to see the International Space Station in the east as well. And we're almost at that point. There it goes. That was the International Space Station that went past. I had it going fast motion, but that's what it will look like.
Well, excellent. It's 2 o'clock. Thank you again, Mrs. Hernandez, for sharing everything you know. Once again, we didn't get to all of the questions, so you'll have to come back next week, participants, to get those questions answered. Do you want to give us a little hint as to what the phenomenon or what we might be seeing next week? A little teaser, if you will.
Well, the moon came up today, so actually
Yeah.
kind of, it's not written in stone for sure. Maybe the moon, or maybe orbital motion. Like,
yeah.
the moon stay out there at all?
Right.
Like, look at it through a telescope. Why is this big gigantic ball of rock just floating there in space? So
I think that is a
one of
huge,
those two.
That is a scientific phenomenon I would love to make meaning of. That's a good one.
Yep. Excellent. All right. Well, thanks for coming, everybody. And we'll see you next
Bye,
week.
everyone. Thank you.